NASA has finally released the new images of Three Eye Atlas, and honestly, this might be the strangest and most troubling anomaly we've seen from this object so far, because these images reveal something that should not happen in nature, a jet firing from the object in a direction that completely breaks the rules of comet physics. And I'm not talking about the forward-facing jet we've all been debating for months. This is something different, something that forces us to rethink the assumptions we've been relying on since day one. So in this video, I'm going to walk you through exactly what these images show, what they mean, why they don't match any known natural explanation, and why Avi Loeb says this might finally be the moment the scientific community has to take this object seriously. Everything begins with a moment that almost seemed too ordinary to matter: the Mars flyby. On October 2nd, Three Eye Atlas passed Mars at around 29 million kilometers. To the average person, that sounds like an enormous distance, but in the scale of our solar system, that's practically brushing past the planet. And orbiting Mars right now is one of the most advanced spacecraft NASA has ever sent into space: the Mars Reconnaissance Orbiter. On board that spacecraft sits the high-rise camera, which is basically the most powerful telephoto camera ever placed around another world. This camera can take pictures of objects on the Martian surface so detailed that you can see individual rocks, rover tracks, and even the shadows of equipment. So when Three Eye Atlas approached Mars, NASA did something unusual and very deliberate. They turned the spacecraft away from its usual scientific targets on the Martian surface and pointed that incredibly powerful camera directly at this mysterious interstellar visitor. It's the kind of decision NASA only makes when they believe something truly important is passing by. For more than a month, the data has been processed, cleaned, and prepared for release. And when the final image set came out, it revealed something we were totally unable to see from Earth. From Earth, we've only ever seen this object from a single fixed angle. That limited perspective has forced us to guess at the true direction of the jets based on two-dimensional photos. It's like trying to understand the shape of a sculpture while only looking at it from one side. But the high-rise camera was sitting in a completely different position in space. It captured Three Eye Atlas from the side, giving us a three-dimensional perspective we simply could not get from home. And this new angle changed everything. For months, all our images suggested a jet that seemed to point almost directly toward the sun. Back in July, when Hubble captured it, the direction toward the sun and the direction of travel were nearly identical. So, of course, the jet looked sun-facing. That made it easy to assume solar heating was the cause. The same mechanism that drives jets on traditional comets. It made the whole thing seem weird, but not impossible. But the geometry had changed dramatically by October. The object's direction of motion had diverged from the sun's direction, meaning the sun was no longer anywhere near the forward line of travel. And with the Mars orbit providing a completely different vantage point, the high-rise camera recorded the jet as it truly was, not as it appeared from Earth's angle. And what it revealed is astonishing. The jet is not pointing at the sun. The jet is not pointing away from the sun. The jet is not angled, curved, or drifting. The jet is firing at a perfect 90-degree angle, a clean, unmistakable right angle, to the direction of the sun. And that alone should be physically impossible. To understand why, we need to go back to the fundamentals of comet physics. Every tail and every jet we've seen across thousands of comets has been controlled by the same three forces: solar heating, solar radiation pressure, and the solar wind. Solar heating occurs when sunlight warms the comet's surface, causing pockets of ice to vaporize. This creates gas jets that always point back toward the light source, the sun. Solar radiation pressure is the force of photons pushing against dust particles. This always drives dust tails directly away from the sun, no matter which direction the comet is moving. And solar wind pushes gas the same way radiation pressure pushes dust, also away from the sun. These forces are the only significant influences shaping comet jets, and they all originate from the sun. So when we find a jet coming off an object at a perfect right angle to the sun, meaning it is not pointing toward the sun, not pointing away, not influenced by radiation pressure, not affected by solar wind, that tells us something impossible. This jet is not controlled by the sun at all. And then it gets stranger. This isn't a tiny puff of gas or a faint cloud. This is a long, narrow, perfectly collimated jet, stretching thousands of miles across the space. To maintain a straight line at that scale requires the jet to remain consistently aligned in the same direction. But 3i Atlas is rotating. In fact, based on light curve measurements, it completes a full rotation every 16 hours. That means any jet tied to the comet's surface should spin with the object. If a rotating comet emits a jet, it behaves exactly like a rotating garden sprinkler. It sweeps through space, tracing out spirals, arcs, or curved patterns. We've seen this behavior in countless comets over decades of observations. It's one of the most basic signatures of comet rotation. But the jet from 3i Atlas is completely straight. This means the emission point would have to remain locked in a fixed direction, despite the entire object spinning beneath it. For a natural object, that makes no sense. The only way to maintain that kind of alignment is if the jet is being controlled or if the emission mechanism is somehow independent of the rotation of the body. And that suggestion, the idea that something might be stabilizing or controlling the jet, is exactly why Avi Loeb believes this may not be a typical comet at all. Now, before jumping to conclusions, let's compare this to what we already know from past comet observations. We've studied thousands of comets across the solar system. We've observed fragmented comets like Shoemaker-Levy 9, which had wild and chaotic tails, but still followed the rules of solar physics. We've seen massive comets like Hale-Bopp that produced multiple jets from different active regions on the surface, and every one of those jets could be explained. We observed Oumuamua, which didn't show a visible jet, but still exhibited faint, non-gravitational acceleration, likely tied to solar heating. But through all of this, we have never seen a jet locked at 90 degrees to the sun. Even when astronomers thought they saw sideways jets in older data, those always turned out to be visual illusions caused by perspective. Once Earth moved slightly in its orbit and we observed the comet from a new angle, the jets snapped back into normal, sun-related positions. But this time, the Mars flyby gives us a geometry we cannot argue with. The sun was in one direction, Mars was in another, 3i Atlas was between them, and the high-rise camera looked almost exactly from the side, giving us a clean line that fully separates sun direction from jet direction. This isn't a projection trick. This isn't a misunderstanding. The jet is real, the jet is perpendicular, and the jet is stable. This is why the scientific world is suddenly paying attention. Avi Loeb believes the jet could be evidence of an engineered system, not because he wants it to be artificial, but because the behavior resembles propulsion more than it resembles natural outgassing. A collimated jet that is not sun-controlled suggests an internal energy source. A jet that stays fixed despite rotation suggests stabilization. A forward-facing jet combined with a perpendicular jet suggests maneuvering or directional thrust. These are engineering signatures, not comet signatures. Now, to be clear, most of the scientific community still leans toward a natural explanation, something exotic, something we haven't seen before, something unusual, but not artificial. Science always tries natural solutions first. But here's the part that bothers many people. NASA's official release of the images did not mention this anomaly at all. They gave basic commentary about brightness, motion, and orientation. Information amateurs have already been discussing for months, but they completely ignored the 90-degree jet. Not even a footnote, not even a sentence acknowledging it. And that silence is fueling speculation more than the anomaly itself. So, where does that leave us? Here's what we can say with absolute certainty. The Mars flyby provided a view we could never get from Earth. The new image proves that at least one jet on 3i Atlas is firing at a 90-degree angle from the sun. There is no natural mechanism we currently know that can produce such a jet. The rotation of the object should curve or twist the jet, but instead the jet remains perfectly straight for an enormous distance. The structure is stable and collimated, which is extremely unusual. And the combination of all these factors makes this the first confirmed case of such behavior in comet history. No matter where you stand, whether you believe this is an internal pressure phenomenon, a geological oddity, an exotic physical reaction, or something more intentional, the fact remains, 3i Atlas just did something we have never observed before. And the truth is, we are only beginning to understand what that could mean. So, what do you all think about this story? Natural phenomenon defying our current models? Technological artifact from an alien civilization? or something entirely beyond our current framework of understanding? Leave your theories in the comments, and if you want to follow every update in this saga, subscribe to the channel because December 19th, 2025, when 3i Atlas makes its closest approach to Earth, promises to be epic. Additional spectroscopic data should be released before the end of November, and those measurements might give us the definitive answer about outflow speeds and material composition. See you next time.